Greetings! In today's video, I am going to go through the thought process and the planning process that I use when I build planes. The way I work with shapes is not intricate, it's not detail-oriented, but I prefer to make things look good as a whole. The many components have to work well together, and I prioritize that over specific components looking best on their own and being highly detailed on their own. The specific plane that I'm going to be showcasing is this. It's the F-18 Hornet. It's a plane I built quite a while ago, and of course it can be bettered through the use of the new blocks in the expansion. However, it's a good starter because it's got quite a simple build, and it's fairly straightforward as a showcase. The first thing that I consider when attempting to create a new plane is I want to figure out what the scale of it is going to be. So I will start with a cockpit. I will use this cockpit block. However, the technique is the same, the thought process is the same, whether you're using a motorcycle seat, so an odd width seat, or a go-kart seat, or whatever kind of cockpit that you may want to build in your plane. You want to start with something that can give you the scale at which you want to build. So if I start with this cockpit and this thruster, I can plan out that this is going to be just about the length of the plane. Now, of course, I have thrusters placed in different places in order to distribute the weight more evenly so that the weight isn't all the way at the back. If you put all the thrust at the back, the weight is going to be all the way at the back. You want your heavy blocks to be distributed a little bit throughout the body so that you aren't dealing with a center of mass that is too far backwards. A different approach, which doesn't start with the cockpit, would be an approach my friend took. He wants to build an SR-71, and he gave me specifically this piece to work with, which is supposed to be the front end of an engine of the SR-71. So if the front end of the engine of the SR-71 has this kind of scale, then one can start building out the general dimensions of the engine, such as this, and then proceed to define from that a general shape that the plane will be able to take in a sort of a wireframe, not very well defined in its shapes, but giving the general idea of how large the plane is going to be in relation to the scale that you have determined of it. Once I have decided how distant I want my cockpit to be from my thrusters, essentially, how the fuselage is going to look, how long it is, what its shape is going to look like, then I generally will start thinking about stabilization. I start to plan out where I want my vertical and horizontal stabilizers to be, how the angles work on them. So I will have this distance sensor hooked into the hinges so that it gives me an angle like this. I will look at reference pictures of any plane that I might be trying to draw inspiration from, and I will figure out the layout of stabilization for the plane. Once I've got that down, I will first of all start planning out the shape language of the stabilizers. In this case, I simply went and looked at reference pictures of the F-18 and came up with shapes that were similar to the ones in the reference pictures. Of course, I piston glitched the powered tail fins into the shapes in order to give them actual powerful aerodynamics properties so that I'm not just drifting in the wind. And then, also through reference pictures, I started to plot out what angles I want my wings to be at. So I will have these modular wings attached to large hinges on the back and on the front in order to give them angles towards the inside, such as this. And now we can already see that the plan that is being built within my head is coming to fruition on the plane itself. So basically, most of the aerodynamic properties of the plane are this component. It is very unrefined, but it should be able at this point to already perform effectively. This is how I hooked up my logic so that both of the rotating servos at the back of the plane would act for pitch and roll at the same time. So I have a 0.6 scale output, a 60% scale output into both of the rotating servos with A and D on the logic gate. And then I have W and S and W are inverted, like they're opposites for the two rotating servos. And for both of them, the speed is 40% and the angle is 20 degrees. And so you end up with a plane that actually begins to work in the fashion of what you intended it to. It's obviously not balanced yet. However, you can start to tune it. Moving forward, I, of course, filled in the wings so that there would not be giant gaps within them. And I started to build out the bottom of the fuselage to accommodate all of my blocks. I have my distance sensor within the nose cone. I have my logic gate embedded within the fuselage. And this is how it starts to look. At this point, I also started to plan out my landing gear by adding perhaps a distance sensor facing the bottom in order to detect the ground and get the landing gear out. Other functions such as that one, I started to implement at this point in the build. One of the functions that I've added into my F-18 Hornet is split throttle. This is where by activation of a button, it allows for the thrust to be present only on one side or on the other when rolling. So this allows the plane to essentially have more yaw functionality without having to use flaps on the vertical stabilizers. This function can also be used in conjunction with flaps on the vertical stabilizers to produce a greater yaw effect. The way this works is I have 4 XOR gates and 2 AND gates. The 2 AND gates are both set to a -1 scale output, and they are hooked up individually to each of the Dragon jets. The XOR gates hold 4 commands: space and E, and then A and D in the white ones. Space activates both Dragon jets and both AND gates. E only activates AND gates. A will activate the corresponding AND gate, and D will activate its corresponding AND gate. In this way, the AND gate will activate to deactivate this thruster only if it receives inputs from all of the gates that output into it. Therefore, the A gate, the space gate, and the E gate. And same for this other AND gate will deactivate this thruster only once it has received inputs from D, E, and space, all at the same time. This produces a result by which if I roll my plane without any thrust active, nothing happens. If I press E to activate the split throttle and I roll my plane, nothing happens either. And if I have space active and I try to roll my plane, nothing happens. It is only when space is active, E is active, and then I try to roll my plane with A and D that split throttle will activate. So That is all of the functionality that I managed to integrate into my F-18 Hornet. As is visible, I have both pitch and roll coded into the same two rotating servos on the horizontal stabilizers. It manages to steer relatively tight, and it's rather easy to fly. Of course, the finishing touches are adding the weaponry, adding a fancy paint job, and doing a little bit of drag glitching so that it doesn't have as much air resistance as it should. And then, of course, it can be tested for its split throttle, which, as you can see, works properly. And there you go. That is my showcase of how I built the F-18 Hornet, my thought process in planning out its shape and its functionality. I hope you enjoyed the video, and I will see you in the future.